The Big Bang theory has lost some validity with the new information discovered by the James Webb Space Telescope, which has made a surprising discovery that is revolutionizing world physics. The recent image captured by this telescope has generated compelling arguments that have surprised experts, putting an end to much speculation. The telescope's most recent discovery is visually stunning and could transform our understanding of the universe. The discussion among experts that this image has resolved centers on the perception of the cosmos. The stunning image taken by the James Webb Space Telescope challenges our understanding of the universe. This finding addresses one of the main problems in astrophysics, the age of the universe and its rate of expansion. Scientists of different generations have been puzzled by this unsolved phenomenon and have carried out numerous studies in search of answers. Cosmologists investigate how the world originated, how it works, how it has changed over time, and how it will end. In the last 100 years, great advances have been made in this field. The Big Bang theory, the most widely accepted theory in cosmology, holds that the universe has been expanding for approximately 13.8 billion years, starting from an extremely hot and dense state. The Hubble constant, which indicates the expansion rate of the universe, is used to measure its growth. However, determining how to measure the Hubble constant is not straightforward, and there are two main methods: local measurements and measurements of the early universe. In space, objects such as stars and Type I supernovae, which are used as standard candles because of their constant brightness, allow astronomers to measure how far away they are and thus calculate the Hubble constant. As the expansion of the universe varies in speed, scientists can calculate the Hubble constant. There are two main approaches. One is the measurement of the early universe. Scientists use reading of the cosmic microwave background radiation, CMB, discovered in the 1960s as the afterglow of the Big Bang. This microwave energy comes from when the universe was only 380,000 years old. Astronomers can determine the age of the universe and its expansion rate by measuring the tiny ripples of temperature and polarization emitted by the CMB. However, there is a problem. These methods do not yield the same result. Local measurements suggest that the universe is expanding faster than the CMB data indicate. Scientists have been hard at work trying to understand why the results differ. To unravel more mysteries of the universe, more studies are underway. The differences in measurements indicate that we do not yet know all the science or that there are errors in one or both methodologies. But thanks to the James Webb Space Telescope, we can peer farther into the darkness of space than ever before, revealing elements, planets, and galaxies we never thought possible. Scientists hoped the data found would help them calculate the Hubble constant. But the first wave of data has revealed new things that don't line up with our expectations. Could this information give us a new perspective on space? We may need to rethink what we know about how the universe works. We might discover particles and forces never seen before, or find that dark energy, an unknown force that accelerates the expansion of the universe, needs to be reconsidered. With each new discovery, our ideas about space have evolved. For example, the cosmic microwave background radiation discovered in 1965 was a strong proof of the Big Bang theory. Before that, scientists thought the universe would last forever, growing at the same rate indefinitely. However, new evidence showed this way was not the case. In the late 1990s, when we discovered that the universe was constantly expanding, we also learned about dark energy and its impact on its expansion. Every time we discover something new, we check whether it fits with our previous knowledge and generate new ways of understanding the universe. If it were not for this, the problem we face in cosmology could lead us to find better ways to understand the universe. Although this problem is complex, it is also exciting because it drives us to develop better tools to explore space. Scientists around the world are interested in this cosmological problem because everyone wants to know more about the universe. Most importantly, this demonstrates how science is always evolving as we learn more about space. SA tension is another concept that goes hand in hand with Hubble tension and refers to how matter is distributed in space. We use this information to create a structure of the universe and see how it has changed over time. Some areas of space have many galaxies clustered together, while others do not. Scientists use different methods to determine the magnitude of this dispersion. One possible way to address this is to look at how different densities of matter, such as galaxy clusters, bend light from distant galaxies. This phenomenon, known as gravitational lensing, allows us to see whether the dark matter is, which does not emit light and therefore undetectable. Scientists also analyze the cosmic microwave background, the CMB radiation, and afterglow from the Big Bang. This light has traveled for about 13.8 billion years, carrying information since the beginning of the universe. By studying the CMB, scientists can understand how the universe was full of irregularities when it formed. However, there is a problem. This data does not match the large-scale irregularities observed in the current universe. The non-spherical distribution of gravity suggests that matter in the early universe was more uniform than seen with gravitational lensing. This suggests that there is something we are not considering in our interpretation, which brings us back to the idea of dark matter and how it works. According to Risi, he and his team were able to redefine their work thanks to the Webb Space Telescope and wanted to find out if a possible error in the Hubble Space Telescope measurements could be the cause of this discrepancy. However, the JWST showed the same deviations, which is worrying. Somewhere between these two observations, there must be a fundamental flaw in our understanding of the universe, Risi said in an interview with an astronomical magazine in the United States. Using the new Space Telescope has allowed us to look deeper into the universe through its sharp infrared view and study cosmic distances with ever more precision. Both dark matter and dark energy are enigmatic components that make up a significant part of the universe, but their nature remains elusive. While black holes have been the leading explanation for certain gravitational effects, there is growing interest in exploring how dark matter and dark energy could influence these cosmic phenomena. Let me know your opinion in the comments box. If you liked the video, remember to like and subscribe. Thank you so much for watching, and I'll see you in the next video.